Okay, in this lesson, I'm going to be teaching you how to graph inequalities on a number line, but that really should be a coordinate plane. Well, why don't we change that right now? Coordinate plane. So we're going to graph linear equations here. All right. The important thing for today is when you have greater than or less than, you're going to use a dotted line. And when you have greater than or equal, less than or equal, you're going to use a solid line. And if you look at the previous lesson where we did the open and closed dot, it's the same idea. The dotted line is kind of like the open dot, and the solid line is like the closed dot. All right? Now this may not make sense right now, but it will in a few minutes. Graph with y equals mx plus b, test point 0, 0, and shade the true part. Okay, now there's other ways to do that, but we'll get to this in a few minutes. Let's first understand what we're doing here. Determine if each one of these points is a solution to x minus 4y is less than or equal to 7. All right, so this is what we're going to do. We're going to see if I put a 0, 0 into this equation, is it going to be less than or equal to 7? Well, let's try it. So let's put, remember this is x and this is y, right? So let's go ahead and try that. Is 0 minus 4 times 0 less than or equal to 7? Well, 0 minus 0 is 0. Is 0 less than or equal to 7? That is true. Right? Let's do B. 7 minus 4 times the negative 1 should be less than or equal to 7. Well, negative 4 times negative 1 is 4, so this is 7 plus 4. 7 plus 4 is 11. Is 11 less than or equal to 7? This is false. Okay? So this is really easy. Let's do the next example, or letter C, sorry. So let's do 9 minus 4 times 2 is less than or equal to 7. Well, that's 8, so 9 minus 8 is 1. Is 1 less than or equal to 7? That's true. Okay? Then we look at 7, 0. 7 minus 4 times 0 is less than or equal to 7. Well, that's 0. 7 is less than or equal to 7. Is that true? Well, that is true. 7 is less than or equal to 7 because it's equal. All right. So far, so good, right? What we want to do now is we want to look at what these would look like on a number line. So give me a second here. Let me add a number line to the, or not a number line, but a graph to this. All right, so let's, what I want to do is I want to graph these points. And I want to see what they look like. So let's see. First thing I'm going to do is I'm going to graph what x minus 4y is less than or equal to 7 kind of looks like. Well, can I quickly graph something that looks like it? Yes. Let's see, the x-intercept. If I do the cover-up method, right, can I graph this using the cover-up method? Yes. X is about 7, so I would put a dot at about 7. You can graph this however you want. And then if I covered up the x, I'd have negative 4y equals 7. So 7 divided by negative 4 is about negative 1.75. So it's about here. Right? Okay, and then, so my line would look something like this. Quick little sketch of it, right? Okay, so it looks something like that, right? Now, what I want you to do now is let's graph those points. 0, 0. If I graph 0, 0, where would it be? Well, 0, 0 is here. I'm going to put a big dot there, right? I'm going to use red just so you can see it better. So 0, 0 is right here. Let's graph the other points. 9, 2. 9, 2 is, let's see, 9, 1, 2 is here. And then let's see what our other points were. What were our other points? We had 7, negative 1, and 7, 0. So 7, negative 1, and 7, 0. Well, that's annoying. Should have thought about that before I moved it. There we go. All right. 7, negative 1. 7, negative 1 is here. And 7, 0 is here. Now, this point was true. This point was true. This point was true. And this point was false. If you look at your notes, that's what happened, right? True, 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 and false. Now, what you end up doing with inequality linear equations is you're going to end up shading one area. So what part of this graph, is the top part true or is the bottom true? Well, obviously all these numbers up here were true. So what you end up doing is you shade in the entire top of the graph. So just slightly shade in with your pencil the top of the graph. Now what that shading means is any number up here is going to work. If I pick any point up here and I put it into this equation, it's going to be true. If I pick any point down here and I put it into this equation, it's going to be false. So let's just try that. Let's pick 2 random points. So let's pick this point right here, and let's pick this point right here. If I put this point into the equation, it should be true. And if I put this point into the equation, it should be false. So let's see if that's true. Negative 9, 5, right? Let's put a negative 9. Negative 9 minus 4 times 5 should be less than or equal to 7. Well, that's negative 9 minus 20, so that's negative 29 is less than 7. That's true. Negative 29 is less than 7. Now, if I do the same thing with the other one, if I put the other point in, which is, what is this? Negative 4, negative 5? Negative 4 minus 4 times negative 5. If I put that point in, well, that's 20. Negative 4 plus 20 is 16. Is 16 less than 7? No, it's false. So that's why it's not shaded. So the whole point of this lesson is to understand what that graph means. You're either going to shade above the line or below the line. If you shade above the line, you're saying everything above that line works. If you shade below the line, you're saying everything below the line works. Now, on this problem, we said less than or equal. And if you remember what I said a few minutes ago, less than or equal uses a solid line. Because it was less than or equal, I used a solid line because numbers on the line do work. If I picked a point on this line and I put it in this equation, it would also work. So numbers on this line work. If it was not, if this equal sign was not there, then numbers on the line would not work and it would only be numbers above the line. I hope that makes sense, but as we go through these problems, I think it will. Okay? All right, so let's go down to actual graphing. You can graph these any way you want, okay? On the first one, I'm going to write this in y equals mx plus b form. On the second one, I'm going to do the cover-up method, okay? So on the first one, let's do it this way. Let's get y by itself. So plus x, I don't want to use green. Give me a second here. So I'm going to add an x to both sides. And I get 2y is less than x plus 8. Then I'm going to divide both sides by 2. And I get y is less than 1/2 x plus 4. Okay? If that doesn't make sense to you, you need to go back to those lessons on y equals mx plus b and re-watch them. But by now, this should be pretty easy for you. So remember, this is my slope, and this is my y-intercept, right? My b. Okay? So let's graph that. Start at 4, dot here. Go up 1, right 2, up 1, right 2, up 1, right 2, down 1, left 2, down 1, left 2. So my graph is going to look like that. Now, got to be careful here. Is it a greater than or equal, or just a greater than or equal, less than or equal, or is it a less than or greater than? It's a less than sign. So remember what we said at the beginning of the lesson. If it's less than or greater than, we use a dotted line. If it's greater than or equal, less than or equal, we use a solid line. So that's what we're going to do here. We're going to use a dotted line. So, dotted line going through there and going this way. Okay? So there's my line. Now it's dotted, so that means the first thing I want to make sure you understand is numbers on this line do not work. Either above the line or below the line works, but numbers on the line do not work, okay? So the second thing you need to do is you need to check it. You need to pick a point and check whether it's true or false, okay? I love checking 0, 0, okay? Because it's such an easy point to work with. So I'm going to check 0, 0. Now, one of two things are going to happen. I'm going to check 0, 0, and it's going to be true, which means I shade down here, or it's going to be false, which means I shade up here. So I'm going to check 0, 0. So let's check 0, 0. We have 0 plus 2 times 0. See how easy it is to work with 0? Is less than 8. 0 plus 0, 0. Is 0 less than 8? Is 0 less than 8? That's true. That means I shade the 0, 0 side. So that means I'm going to shade down here. I'm going to shade this whole bottom section in. And that's much easier to do with your pencil. But that's what you would do. You would shade in this whole bottom area because everything down here was true, right? That's what we're saying. This is true, and everything up here is false. If I picked any point up here and I checked that point in this equation, it would be false. And you can try it. Pick a point and put it in here and see what happens. But you'll notice everything up here is false, everything down here is true. The shaded region means the true answers. You don't have to write this true and false on your paper tonight, but that's just a nice visual to help you understand that. Okay? All right, let's do another example. Okay, in this problem, instead of doing the y equals mx plus b way, I'm going to do the cover-up way. So remember what the cover-up method was. The cover-up method was you cover up the, ooh, that's not what I wanted to do. Give me 1 second here. Let's see if I fix that. All right, so the cover-up method is this. Can't believe it. The cover-up method means you cover up the x to find the y-intercept, and you cover up the y to find the x-intercept. So I'm just going to do that real quick. I'm going to cover up the y first, so ignore this. Basically, in your mind, you would kind of just scratch this out, right? Don't even look at it. So I have x is greater than or equal to 12, so at 12 I put an x. So dot, dot, about right here would be a 12, right? Somewhere right around there. And then to find the y-intercept, I cover up the x. So what I do is I cover up the x, which basically means get rid of it, and I have negative 3y is greater than or equal to 12, so y is negative 4. So y is negative 4, so I got a dot here, right? And then I go ahead and make that graph. Now be careful once again, we're going to make a line. Is it going to be a dotted line or a solid line? Well, hopefully you realize it's going to be a solid line because it's equal to. So that's what I'm going to do. I'm going to make a solid line. And I just did a dotted line, and I wanted a solid line. All kinds of stupid mistakes here. I want a solid line, right? Going in both directions. And then, what do I want to do? Well, I need to check a point. And what point did I say that would be a good point to check? I would check 0, 0. So either 0, 0, I'm going to check this point. Either 0, 0 is going to be true, and that means I shade up here. It's going to be false, and then that means I shade down here. So let's try it. Go back to my equation, put 0 in, 0 minus 3 times 0 is greater than or equal to 12. That means 0 is greater than or equal to 12. Is that true or false? That's false. That means 0, 0 is false. That means down here is true, which means this is the part I'm going to shade in. The whole bottom section here I would shade in. Okay? There you have it. All right, let's do a couple more examples. I think we have a couple more, not too many. All right, next problem. Let's get y by itself, okay? So distribute the 1/2. I would get 1/2 x plus 1 plus 3y is less than 8. Then I would subtract 1 from both sides, or add a -1 to both sides. I would get 1/2 x plus 3y is less than or equal to 7. Then I would subtract 1/2 of an x from both sides, and I would get 3y is less than or equal to -1/2 x plus 7. And then I would divide everything by 3. This is where it gets kind of weird, but I would get y is less than or equal to -1/2 divided by 3 is 1/6, so that's 1/6 x plus 7/3. Okay, so let's go ahead and graph that. This one's going to be really hard to graph. 7/3. In fact, I'm tempted to turn this into a 7. Let's do that. Let's turn this into a 7, just so it's easy to graph. So let's change that 8 into a 7. So that would be a 7. That'd be 7 minus 1 is 6. And that would become a 6, and so this would be a 2. So then you'd have 6 over 3, which makes it 2. Go ahead and change your work to make that work. But if you change that to a 7 from the beginning, by the time you're done, it's a 2. It's a much easier problem, okay? Hopefully I do that in class too. All right, so let's graph this. There's my slope, there's my y-intercept. So go up to 2, put a dot there, right? And then what does that mean? Go down 1, right 6, right? Or up 1, left 6, right? There's my dots on my line. Determine if it's open or if it's a dotted line or a solid line. Well, in this case, it's a dotted line. So I'm going to make a dotted line. Okay. And then what do I have to do? Well, then I have to check it. So I'm going to write check. And what am I going to check? I'm going to check 0, 0. Why did I pick 0, 0? Just because it's easy. So 1/2 of 0 plus 2 plus 3 times 0 should be less than 7, right? Because I changed that 8 to a 7. Half of 2 is 1, so this is 1 plus 0 is less than 7. Is 1 less than 7? Yes, that's true. So that means 0 is true. Anything up here is false, so that means I shade this area right through here, right? This whole thing shaded in, right? Got it? All right. We got a couple more examples. The last two are real easy. In this problem, I'm just going to start off by distributing. So I'm going to get 2x plus 2 is greater than or equal to 1/4 y minus 1. Then I'm going to add the 1 to both sides. And I get 2x plus 2 plus 3 is greater than or equal to 1/4 y. Then I'm going to multiply both sides by 4 to get rid of the 1/4. And I get 8x plus 12 is greater than or equal to y. And if I want to flip that around, I can. Y is less than or equal to 8x plus 12. And that's what I want to graph. All right, so I go up to plus 12, which is, let's see, 1, 2, so it's about right there, right? There's my first dot. And 8 means up 8 right 1, well, that'd be off the graph. So let's go down 8. 1, 2, 3, 4, 5, 6, 7, 8. Right, left 1, so I'd be here. Down 8, 4, 8, left 1, right here. Okay, look at this. What does that mean? Well, it's greater than or equal, which means solid line. So I'm going to make a solid line in both directions. Okay, then what do? Well, I check it. What do I check? I check 0, 0. There's only one time you can't check 0, 0. If 0, 0 was on the line, you couldn't check 0, 0. You'd have to check some other point. But almost always 0, 0 is not on the line, so you can check 0, 0. So let's put that in there. 2 times 0 plus 1 should be greater than or equal to 1/4 of nothing minus 1. Well, 0 plus 1 is 1, times 2 is 2, so we have 2 is greater than or equal to -1, which is true. Which means 0, 0 is true. That makes these false, so this is the side I shade. All this over here, right? All right, down to 2 more examples. Next one's a little bit harder. How do I graph y is less than 5? Well, if this was y was equal to 5, how would you graph that? Well, hopefully by now you remember this. You go up to y equals 5, and you would make a horizontal line there. So that's exactly what we do. We know it's going to be a horizontal line here, but the question is it solid or dotted? Well, if it was equal to 5, I'm sorry, since it's less than 5, that means I use a dotted line, right? So it's going to be a dotted line. And then which side do I shade? Well, I'm going to check 0, 0. So I don't have an x number, so I just put the y in. And I just get y is less than 5. Really easy to check. Is 0 less than 5? I'm sorry. 0 is less than 5. Is 0 less than 5? Yes, that's true. So that means 0, 0 works. So that means I shade down here. Okay? Real easy. Do the last one. On this problem, when x equals a number, since y equals a number is horizontal lines, x equals a number is vertical lines. So you go to x equals -2, and you're going to make a vertical line, right? Open or close dot. Well, it's equal to, so that means close dot. So there's going to be a closed dot like this. Then what do I have to do? Well, I have to check it. What am I going to check? Well, 0, 0 if I can. So I can't put my y number in, I can only put my x in. So I get x is greater than or equal to -2. Is 0 greater than or equal to -2? Yes, that's true. So that means this is true. That means this is false. And that means I graph everything over here. I shade in over here. All right. And that's all there is to it. The testing of the point is the new stuff. The solid and dotted line is the new stuff. Everything else should be things that you should be good at now. It's only one new thing. So good luck with this. And if you need help, I'm always there. All right? Good luck and have fun.